Hello and welcome to another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 10, Lesson 11 on solving rational equations. In other words, we're going to be solving some equations that have fractions in them. Let's jump right into it. All right, cross multiplication. Equations involving fractions arrive frequently in mathematics. The key to working with them is to manipulate the equation so the fractional nature of the equation is eliminated. The most common form of this practice is cross-multiplying. And I talk about this to my students all the time. The problem with solving equations that have fractions in them is that they have fractions in them. And the way that you always solve an equation with a fraction in it is by getting rid of the fraction. All right, and you've been doing this first technique for quite a few years, but let's review it anyway. Exercise number 1. Use the technique of cross-multiplication to solve each of the following equations. All right, so cross-multiplication is how we tend to solve fractional or rational equations when we have a fraction equal to another fraction. And as you may recall, the way that we do cross-multiplication is to simply multiply these two, the numerator there with the denominator there, and multiply those two as well. I think I'm going to go back to blue. I don't know how my pen started off on red. So what we end up having is we end up having 5 times 4x plus 5. Let's do that, equals 2 times x minus 1. Now we have to make sure that we're doing distribution, right? And that's why I've got the parentheses around the 4x plus 5 and around the 2x minus 1. But once we do the distribution, it's simple enough to do this, and we get 20x plus 25 is equal to 2x minus 1. And suddenly we've transformed an equation that's got fractions into it, right, our original one, into an equation that doesn't have fractions. I suppose this one didn't either. So as soon as we cross-multiplied, the fractions were gone. And now we're really just, yes sir.
2x minus 2.
Oh my goodness, 2x minus 2. Thank you, Joey. Here I'm talking about distribution and chewing gum and walking at the same time. It's just not happening. Anyway, it's simple enough now to subtract a 2x from both sides and subtract a 25 from both sides in order to get all of my x's on one side and all of my non-x's on the other side. So I'll get 18x is equal to negative 27 and divide both sides by 18. Negative 27 divided by 18 can be reduced, and I'll divide both numerator and denominator by 9. That looks nothing like a 2, and I'll get x equals negative 3/2. I think this is as good of a time as any, especially because we're working on solving equations today, to remind you that, of course, your graphing calculator, especially the one like the TI Inspire, can easily check to see if a value of x is a solution to an equation. So just really quickly, right, you know, this is interesting. Here I've got a fractional equation and my answer itself is fractional. Notice, of course, I can bring my TI Inspire out. I can take that negative 3/2, I can store it in x, I can then type my equation out, 4x plus 5 divided by 2 equals x minus 1 divided by 5, and of course my calculator tells me true, which it wouldn't have if Joey hadn't caught that -1 versus -2. I would have been like, man, that is an ugly answer. It would have told me false here. But since my calculator tells me true, I know that x equals negative 3/2 is a solution because when substituted into the equation, it makes the equation true. All right, we'll probably be using the calculator just a little bit more in this lesson to check some solutions. It is a great tool. Never forget that you have it. All graphing calculators should be able to check equations to see if you have the right solution. All right, now cross-multiplication equations can certainly get more challenging than the one that we just did, and letter B is a good example of it. You have all the tools that you need to solve letter B, so I'd like you to pause the video right now and see if you can solve this equation by cross-multiplying. All right, definitely a step up from what we did before, right? We're going to multiply these two and multiply these two. So we're going to get x plus 1 times x minus 6 is equal to 2 times 2 minus x. First thing I'm going to do is multiply all this out. That's going to be x squared minus 6x plus x minus 6. And on this side, I'm going to have 4 minus 2x. Here I'll have x squared minus 5x minus 6 is equal to 4 minus 2x. Now, a lot of students, even though they could have solved this problem, let's say 4 units ago when we were working on solving quadratic equations, sometimes get to this point and they go, I don't know what I'm supposed to be doing here. What I want you to always do when you're solving an equation that has an x squared in it is be biased. That's the way, I know bias is a terrible, terrible word, but I want you to be biased towards the zero product law. In other words, I want you to look to get everything equal to 0, factor, and then set each factor equal to 0. If you prefer the quadratic formula or for some strange reason completing the square, that'll work as well, but try to think, I've got an x squared, I need to get everything equal to 0, and then probably factor or use the quadratic formula. So let's keep going. Let's, I suppose, add a 2x to both sides and subtract a 4. I'm doing all of that to get it equal to 0. I'm going to get x squared minus 3x minus 10 is equal to 0. Completing the square would be a real pain at this point because that linear coefficient is odd. You could use the quadratic formula. I find factoring at this point to be pretty quick. I'll have x minus 5 and x plus 2. If I set x minus 5 equal to 0, again using the zero product law here, I'll get one solution, x equals 5, and x plus 2 equals 0. I'll get another solution, x equals negative 2. There we go. Awesome. So again, you know, the primary focus here, though, is the idea that we're starting with an equation that has a fraction in it, or fractions in it, as the case is, in both of these two, and we're cross-multiplying in order to get rid of the fractional nature of the equation. Okay, and anytime you have a fraction equal to a fraction, I would certainly suggest doing cross-multiplying. But now let's move on from that scenario because we need to get into the ones that are truly unique or new to Algebra 2. I'm going to show you something called clearing the denominator. Since this technique, i.e. cross-multiplication, should be familiar to students at this point, we will move on to a less familiar method when more than 2 fractions are involved. The next exercise will illustrate this process. Exercise number 2. Consider the equation 1/2 minus 9 divided by 4x is equal to 3 divided by 4x. Letter A. What is the least common denominator for all 3 fractions in this equation? In other words, in our last lesson, we looked at how to add and subtract fractions, okay? Rational fractions that have variables in the numerator and denominator. I want you to look at the 2, the 4x and the 4x, and ask yourself, what is the least common denominator that you could get if you were to combine all 3 fractions? Now, we're not going to combine all 3 fractions, but if you were going to, what would that denominator be? Pause the video now and think about that for a moment. Well, these two already have a common denominator of 4x. I could make that thing into a 4x by multiplying top and bottom by 2x, and therefore the least common denominator in this problem is a 4x. And I know that that's a lot of space to give you to write down 4x, but that's because I need some space in letter B. So let's take a look at letter B now. Multiply both sides of this equation by the LCD, the least common denominator, to clear the denominators. This should happen due to cross-canceling when multiplying fractions. All right, so this is really cool. This is a technique that is commonly referred to as clearing out the denominators. Now remember, I've got something called the multiplication property of equality. The multiplication property of equality says that I can multiply both sides of an equation by anything I want as long as I multiply by the same thing. So what I'm going to do is I'm going to multiply both sides of this equation by that least common denominator quantity. Now I'm not actually multiplying by a denominator. I'm just saying the least common denominator is 4x, and I'm going to multiply both sides by 4x. And technically, I'm really multiplying by 4x over 1. And a lot of students like seeing that because they know how to multiply 2 fractions, okay? And now what I'm going to do is I'm going to distribute that multiplication. Now I'm going to rewrite it a little bit here. I've got 4x over 1 times 1/2 minus 4x over 1 times 9 over 4x equals 4x over 1 times 3 divided by 4x. So the cool thing is, if I do this correctly, what will happen is all of the denominators will cancel, okay? Here's what I mean. 2 cancels into 4 and leaves me with a 2 up here. In this particular case, a 4 cancels a 4, and x cancels an x, and all I'm left with are 1s there and there. Finally, here, same thing happens. A 4 cancels a 4, and x cancels an x, and I'm left with a 1 and a 1 here. And notice I'm left with 1s in all of my denominators. So what do I have left here? I've got 2 times 1, which is just 2, minus 1 times, nope, I lost that x. Sorry, 2x times 1, which is 2x. Here I've got 1 times 9, which is 9. And here I have 1 times 3, which is 3. So by multiplying both sides by 4x, what's happened is all of my denominators have canceled, and I've been left with 2x minus 9 is equal to 3. Let's take a look at letter C. Now, solve the equation from B that contains no fractions, no denominators, right? Really doesn't. All of my denominators have canceled to be equal to 1, and when we have a denominator equal to 1, like 2 over 1, that's just the number 2. Or 2x over 1, that's just the quantity or the expression 2x. And now, of course, it's very easy. I get 2x minus 9, 2x minus 9 is equal to 3. Add a 9 to both sides, I'll get 2x is equal to 12. Divide both sides by 2, and I'll get x is equal to 6. All right? Clearing out the denominators. Basically, multiplying both sides of a fractional equation by some quantity that it will cancel out all of the denominators. And the thing that will cancel out all the denominators will be any common denominator for all the fractions, but the least common denominator is nice because it leaves you with the least redundancy. If I could have multiplied everything by 8x or by 12x or something, and that would have all canceled the denominators, but it would have left me with a more complicated equation here to solve. Again, don't forget, I could easily check that x equals 6 is a solution by storing it in x, typing in that equation, and I would see that it was true. Let's take a look at more of these that are a little bit more complicated. Removing denominators. It should be noted that we just need to multiply both sides of the equation by something that will cancel out all the denominators. Sometimes that quantity contains a variable, like in the last problem. Sometimes it does not. Let's take a look at exercise number 3. Which of the following values of x solves x minus 4 divided by 6 plus x minus 2 divided by 10 equals 31 divided by 15? Awesome, right? So I'm looking at 6, 10, and 15, and I really just need any number, literally any number that all three of those things would divide into. Now, that would be a common denominator of all three, 6, 10, and 15. But the least common denominator, right, if I were going to add those three fractions together, the least common denominator would be 30. So 30 is a very convenient thing to multiply all the fractions by, okay? Now, what will that look like? It'll look like 30 over 1 times x minus 4 over 6 plus x minus 2 over 10 equals 30 over 1 times 31/15. Okay, now I need to distribute this through, and I'm going to start doing a little bit of a move pretty soon where I just immediately do this right from the beginning, where I just automatically distribute it instead of writing that first line. Let me make that look like a 30 instead of some weird Greek letter. Now it's a 30 with a dot in it, whatever. All right, so what do I do now? Well, 6 cancels into 30 and leaves me with a 5. 10 cancels into 30, leaves me with a 3. 15 cancels into 30 and leaves me with a 2. And notice all of those denominators have canceled. What am I left with? Well, I'm now left with 5 times x minus 4 plus 3 times x minus 2 is equal to, 2 times 31. The red pen is just coming out like everywhere and in the most random spots. And I've got no denominators, right? Now I can distribute 5x minus 20 plus 3x minus 6 is equal to 62. Combine like terms, 3x and 5x is 8x. Negative 20 and negative 6 is negative 26 is equal to 62. Add 26 to both sides. 8x is equal to 88. Divide both sides by 8. And x is equal to 11. And that's it, right? By multiplying both sides of the equation by 30, I literally can cancel a 6, a 10, and a 15. All of them will cancel out. And the reason why is that 6, 10, and 15 are all factors of 30. I'm going to say that again, right? 6, 10, and 15 are all factors of 30. And therefore, 30 will cancel all three of those numbers. Okay. Now let's get into ones that are a little more complicated. These equations can involve quadratic expressions as well. The key, though, remains the same. Multiplying both sides of the equation by the same quantity, to cancel out all the denominators. Let's take a look in exercise number 4. Solve each of the following equations for all values of x. Letter A. 1 divided by 10, or 1/10, minus 1 divided by x is equal to 1 divided by 5x minus 2 divided by x squared. Now again, you can think about it in terms of common denominators. You can also think about it in terms of what will cancel what. I like thinking about it in terms of common denominators because we just did a lesson on adding and subtracting fractions. So if I were to look at all these denominators, 10x, 5x, and x squared, I could make them all into a least common denominator of 10x squared, right? But I would need a 10, right, because the 5 and the 10, and I would need an x squared because of x to the first and x to the second. So my least common denominator in this case is 10x squared. Okay, so what am I going to do? I'm going to multiply both sides of the equation by 10x squared, and I'm just going to immediately do this. 10x squared over 1 times 1/10 minus 10x squared over 1 times 1 over x is equal to 10x squared over 1 times 1 over 5x minus 10x squared over 1 times 2 over x squared. Now again, you could multiply by 50x to the 6th if you wanted to, all right? It just has to cancel out all the denominators. The least common denominator is your best choice, all right? So let's take a look. Here, my 10s cancel. Here, an x to the first cancels with a single x to the first, so I still have an x to the first there. Here, 5 cancels with 10, leaving me with a 2. And x to the first cancels with 1x up there, leaving me with an x to the first. Here, x squared and x squareds cancel, leave me with just the 10. So what do I end up having? I end up having x squared times 1, which is x squared. I have 10x times 1, but there is that minus there. Over here, I have 2 times x to the first, minus, and here I have 10 times 2, minus 20. Now look, at this point, we've got no denominators. We've taken an equation that had fractions in it, and we've produced an equivalent equation that doesn't have fractions in it. If you haven't gone through this one yet, pause the video now and see if you can finish solving this equation. All right, remember, if an equation's got an x squared in it, I want you to be biased towards the zero product law. So here we go. I'm going to subtract a 2x, subtract a 2x, add a 20, add a 20. That's going to give me x squared minus 12x plus 20 is equal to 0. I'm now going to factor that, looking for two numbers with a product of 20 and a sum of negative 12. Those are going to be x minus 10, here we go, and x minus 2. So x minus 10 is equal to 0 and x is equal to 10. and x minus 2 is equal to 0, and x is equal to 2. The zero product law, one of the most important of all equation solving techniques. It allows you to solve tons of equations that have an x squared or higher powered terms in them. Okay, so let's take a look at one that's very similar, letter B. We have 1/2 plus 3 over x minus 1 over x squared is equal to 1 over 4x plus 1 over 2x squared. Now, this one's kind of similar to the last one, so I'd like you to pause the video now and see if you can figure this out. Again, as a first step, think about what would be the least common denominator if you added or subtracted, whatever, all these fractions together, and then multiply each one of those fractions by that particular expression. Pause the video now and go ahead and do that. All right, very similar to the last one. I've got the 2 and the 4, so the least common denominator is going to involve a 4. I've got an x and an x squared, so the least common denominator is going to have an x squared in it. So my LCD in this situation, very, very similar to the last problem, 4x squared. So here we go. All right, I'm going to give myself plenty of room. I've got 4x squared over 1 times 1/2 plus 4x squared over 1 times 3 over x minus 4x squared over 1 times 1 over x squared is equal to 4x squared over 1 times 1 over 4x plus 4x squared over 1 times 1 over 2x squared. Here we go. In our first problem, we have a 2 canceling into a 4, leaving us with a 2. In our second one, we have an x canceling into an x squared, leaving me with an x to the first. In the third expression, we have an x squared and an x squared, leaving me just with the 4. On the other side of the equation, we have a 4 canceling a 4 and an x to the first canceling with an x to the second, leaving me with only x to the first. Here we have an x squared canceling an x squared and a 2 going into a 4, leaving me with just the number 2. Now I have to be careful. I've got 2 times x squared times 1. That's 2x squared. Here I have to be careful. I have a 4x times 3, so that's going to be a 12x. And here I have a minus 4 times 1, so that's just 4. On the other side of the equation, all I've got left here is an x to the first plus, and all I have left here is 2. So after I've multiplied each quantity by 4x squared over 1, I'm left with an equation without any denominators in it. So I'm going to use the zero product law. Subtract x, subtract 2. Subtract x, subtract 2. We've got 2x squared plus 11x minus 6 is equal to 0. This is a slightly more challenging trinomial, so I'm going to pause for a moment to remind ourselves about what's called the AC method of factoring. I'm looking for two numbers that have a product of 12 and a sum of positive 11. Those two numbers are positive 12 and negative 1. I can then factor this as 2x squared plus 12x minus x minus 6 is equal to 0. I'm now factoring it by grouping. Factor a 2x out of the first two. Factor a negative 1 out of the second two. Leaving me with that common factor of x plus 6. Boy, I just keep making this page longer and longer. X plus 6 times 2x minus 1 is equal to 0. Set x plus 6 equal to 0, and I'll get x equals negative 6. Set 2x minus 1 equal to 0, and I'm going to get x equals positive 1/2. Awesome. Again, don't forget, you can store either one of these in as x, type out that rather complicated equation, right? Can you imagine trying to check this thing with an x equals 1/2? That would be a beast, all right? But you can do it easily using those graphing calculators with the store command. All right, let's keep going. Extraneous roots. Just when you thought we'd left them behind after square root equations. Because fractional equations often involve denominators containing variables, in fact, pretty much every one of them that we looked at today did, except for that one multiple choice, it's important that we check to see if any solutions to the equation make it undefined. These represent further examples of extraneous roots. Now, I've kind of sidestepped this issue the whole time so far. None of the equations so far that we solved had extraneous roots. And we probably should have been checking them from the get-go, but extraneous roots only come up in more complex problems like the ones that we're going to look at in exercise number 5. So I kind of avoided the issue until now. But let's take a look at exercise number 5. Solve and reject any extraneous roots. Letter A. X plus 1 divided by x plus 5 plus 18 divided by x squared plus 8x plus 15 equals 9 divided by x plus 3. Now, this is a rather complicated equation, and in order to figure out what we should multiply each thing by, in order to figure out what our least common denominator is, I go back to our last lesson on adding and subtracting fractions, and I say to you yet again, factor any denominators that can be factored. So the first thing I'm going to actually do in this problem is I'm going to rewrite it, all right, but I'm going to factor the denominators. Now there's nothing I can do to the first one, but that second fraction, I can factor that as x plus 3 times x plus 5. And again, there's nothing I can really do to the fraction on the right side of the equality. But notice, right? Here I have an x plus 5, here I have an x plus 3, and here I have an x plus 3 and an x plus 5. Now the only thing that's going to cancel an x plus 5 is an x plus 5. And the only thing that's going to cancel an x plus 3 is an x plus 3. So what I'm going to do, right, is my least common denominator would be x plus 3 times x plus 5. So that's what I'm going to multiply everything by. Okay? Here we go. I'm going to have x plus 5 times x plus 3 all over 1 times x plus 1 over x plus 5. You know what? I'm going to put both of those in parentheses. It sure doesn't hurt. Plus x plus 3 times x plus 5 all over 1 times 18 all over x plus 3 times x plus 5 is equal to x plus 3 times x plus 5 all over 1 times 9 over x plus 3. Again, all I'm doing is multiplying both sides of the equation by x plus 3 times x plus 5. Okay, it's time to cancel. Here we go. X plus 5 cancels x plus 5. X plus 3 cancels x plus 3. X plus 5 cancels x plus 5. And x plus 3 cancels x plus 3. Notice how I was able to put a line through each one of those denominators. Therefore, I've got no fractions left. Now what I have left is not a piece of cake. In the first particular manipulation, I've got x plus 3 times x plus 1. And we'll worry about that in just a bit. Plus, in the second one, all that was remaining was the 18. And in the third one, what I have remaining is 9 times x plus 5. So I've still got some work to do, right? I definitely have work to do. First thing I'd like to do is I'd like to multiply all of this out and then combine it with the 18. So that's going to be x squared plus x plus 3x plus 3 plus 18. And on this side, I'll distribute the 9, and I'll get 9x plus 45. On this side, I'm going to get x squared plus 4x plus 21, and nothing on this side, just 9x plus 45. Yet again, we see we have an equation involving an x squared, so I want to be biased towards the zero product law. So I'll subtract a 9x and a 45 from both sides. Okay, and I'll be left with, maybe take all of this up here. I'll be left with x squared minus 5x, 21 minus 45 is negative 24, is equal to 0. Woo! All right, so zero product law, two numbers that have a product of negative 24 and a sum of positive 5, that's going to be positive 3 and negative 8. So x minus 8 is 0, x is equal to 8, x minus 3 is equal to 0, and x is equal to, x plus 3 is equal to 0, my apologies, and x equals negative 3. All right, so we've got these two values, right? X equals 8 x equals -3. Awesome, Blossom, right? I mean, so why would either one of those values, let me kind of move this up here, so we can see our two solutions down here. Why would either one of those values be problematic in this equation? Well, just for a moment, let's check them. Okay, I think that's worthwhile. Let me just clear this out. Actions, clear history. Let me take that 8. I'm going to take 8. I'm going to store it in x. All right, and I'm going to type the equation in. Okay, so and I know it's going to take me a little bit. Just bear with me. X plus 1 divided by x plus 5 plus 18 divided by x squared plus 8x plus 15 is equal to 9 divided by x plus 3. So this is for our solution of x equals 8. And the calculator says true. Awesome. Right? X equals 8 is the solution. Now let's take -3. Let's store it for x. Now the cool thing is I don't have to type out the equation again. I can just keep hitting my up arrow until I get my equation back. Right? So I haven't hit enter yet. I've got x equals -3. And now I get undef equals undef. Right? And what it really is undefined equals undefined. Doesn't say true, doesn't say false. I kind of wish it said false, but it says undefined is equal to undefined, which really means x equals -3 is not a solution. And you can really see why, right? X equals -3 makes this fraction have a denominator of 0. It also actually makes this fraction have a denominator equal to 0 because there's that fraction or that factor of x plus 3 as well. If a solution makes any of the denominators equal to 0, it is an extraneous solution and it needs to be rejected. It needs to be thrown away. Now you can easily get two values that are both perfectly okay and don't make any of the denominators equal to 0. But if any of the values make the denominators 0, then what will happen is that is undefined, and therefore it must be rejected. So this is extraneous. All right? By the way, if it makes one denominator undefined on one side of the equation, it is most certainly going to make another denominator undefined on the other side of the equation. You'll never get something like 5 equals undefined. Okay? So it's going to happen sometimes that you will get a denominator equal to 0 on both sides of the equation. It will produce a solution that seems like it's correct, but all you'll have to do is just glance at the equation and say, oh, I got these two answers. Do either one of them make any of the denominators equal to 0? And if you go back and you look at all the problems that we did at the beginning before we even mentioned extraneous solutions, none of those made the denominators equal to 0, which is why I kind of just sidestepped the issue. Okay, I probably shouldn't do that again on video. But just kind of keep that in mind, okay? So, in all of these problems, they're very, very similar to when we added and subtracted fractions. We want a factor to identify what we should multiply by, multiply both sides of the equation to eliminate the denominators, solve the equation, and see if any of the values make any of the denominators into 0. So pause the video now and see what you can do in letter B. It's pretty challenging, but start by factoring that first denominator. Okay, here we go. So first things first, I'm going to factor that denominator, and probably to no great surprise, it's x plus 6 times x minus 2. I'm going to put that denominator and numerator in parentheses immediately. No need to do that here. Now, side note, before we even move on, okay, I can identify the only two values of x that will be problematic. And those values would be x equals -6 and x equals +2. Okay, so if we're going to have extraneous roots, they would only be -6 and 2. So if neither one of my answers are -6 nor 2, I'm good to go. Okay, now also that's what I want to multiply everything by, x plus 6 and x minus 2. So let's do it. All right, I'm going to have x plus 6 times x minus 2 all over 1 times 4 over x plus 6 times x minus 2 plus x plus 6 times x minus 2 all over 1 times x minus 1 divided by x plus 6 equals, I'm just going to keep moving that thing around apparently, x plus 6 times x minus 2 all over 1 times 1 over x minus 2. And let's do some canceling. Everything cancels here, and we're just going to be left with the 4. I like that. Here, x plus 6's cancel, and I'm left, unfortunately, with a further algebra problem, but we'll get there. Here, the x minus 2's cancel, and all I have is x plus 6 times 1, so I'm just going to write it as x plus 6. All my fractions are now gone. We just have to FOIL that out. That's going to be x squared minus 2x minus x plus 2. Be careful of that. It's equal to x plus 6. Let's combine some like terms over here. 4 and 2 is 6. X plus 6. Bias towards the zero product law. Get everything equal to 0. Oh, that's interesting. My 6's cancel. I get x squared minus 4x is equal to 0. No trinomial here, just factoring a GCF out. Right, I'll get x times x minus 4 is 0. That means either x is 0 or x minus 4 is 0. And that means either x is 0 or x is 4. And now the only question is, are either one of them extraneous? Well, you might think x equals 0 is extraneous, except it's not going to make any of these denominators 0. X equals 4 isn't going to make any of these denominators 0. The only two problematic values would have been x equals 2 and x equals -6. So these are both good. Both good. All right. And that's it. Let's wrap this up. All right, so today we solved equations that had fractions in them, also known as rational expressions. Now, when we did that, right, our whole purpose, whether it was cross-multiplying in the first problem or clearing out the denominators in all of the other problems, what we were doing is we were multiplying both sides of the equation by a quantity that would get rid of the fractions. The problem with fractional equations is that they have fractions in them. And to solve them, our first step is always to multiply both sides of an equation by something that will cancel out all of the denominators. All right? Once we've canceled out all the denominators, and to do that, we multiply both sides typically by the least common denominator, then what we can then go on to do is solve the equation using standard algebraic techniques, oftentimes using the zero product law. The only piece that we need to be concerned with are those more complicated problems where we might factor to identify what to multiply by. We can come up with extraneous roots in those situations. Those are easy to spot. Get your answers for x. Think about all the denominators. If it makes any of them equal to 0, it's an extraneous root and you got to reject it. If it doesn't make a denominator into 0, then it's an acceptable solution. Of course, you can always tell whether something is or isn't a solution by using your graphing calculator to check. All right. Well, I want to thank you for joining me for another Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.